All right, so today we're learning how to solve rational equations. And the first two we have a little bit easier problems because we already have one fraction equals one fraction. If we don't have just one fraction, then we need to make whatever that left or right side is into one fraction before we can use cross multiplication. So we can multiply so that this times that would equal to this times that. So basically 5 times x minus 4 equals 4 times x plus 4. Now you can go ahead and distribute this in your head so that you get 5x minus 20 and 4x plus 16. So you don't actually have to show that step, but it's a good thing to remind yourself this is a polynomial and so is this, and I need to distribute to both. If we subtract 4x to both sides, and we add 20 to both sides, then we get x equals 36. Now, to make sure that this works, we do want to check it and say 5 over 36 plus 4 is 40. And this would be 4 over 36 minus 4 is 32. Well, this simplifies to 1/8, and so does this. So that works. Also, when I plug it in, I want to make sure that I don't create a denominator of 0. So this is good. For number 2, we can say that 5 times 7 is the same as y times y minus 2. So 5 times 7 is 35. Y times y minus 2, we distribute. Okay, now we could do completing the square because we've got a nice even term here. Or we can subtract 35 and factor. So if I just subtract 35 to both sides, then that goes to 0. And then this will factor nicely. And then we can use our zero product property and say that if they each equal 0, then y would be 7 and negative 5. And then let's go ahead and check. So if y is 7, then we have 5 over 7. Equals 7 minus 2 over 7. Well, 7 minus 2 is 5, so that works. And then negative 5, if we say 5 over negative 5, and negative 5 minus 2 over 7, that's negative 7. This both reduce to negative 1, so both of these work. Now the trick is when we have a problem where we don't have a common denominator on one side. So we could make a common denominator, or we could actually recognize that m minus 2 and m minus 2, they already have the same denominator. So if I subtract this fraction from both sides, then that one goes away, and I'm left with negative 2/3 equals 2 minus m over m minus 2. I now have a fraction on each side, and I can cross multiply. There are other things that we could do as well, so we don't always have to do it this way, but this one will work as well. So negative 2 times m minus 2 is negative 2m plus 4 equals, and then 3 times 2 minus m is 6 minus 3m. If I add 3m to both sides, then I get m, and I'm going to go ahead and minus 4 to both sides. So m equals 2. Okay, so then we need to plug it back in and see if that works. So I'm going to go back to my original problem, the one that I canceled out, and say, okay, if I plug in 2, I get 2 minus 2. Uh-oh, that goes to 0. So this is not good, and we end up with no solution. We cannot divide by 0 here, so this is no solution. So now sometimes we've got a word problem, but we're going to use the same method to solve this. So our fourth question is your starter deck for a collectible card game has 50 cards. Okay, the deck contains 17 creature cards. You add creature cards to the deck until it contains 50%. Okay, so you're starting at 17 out of 50, and we have creature to total. And we're adding some unknown amount. So I'm going to go ahead and say plus x, because this value right here has to be the same amount. And so now, and we want that to be 50%. Well, 50% is 50 over 100, and that reduces to 1/2. And so the reason we did that is so that it's a simplified fraction, so I don't have to simplify later. So 17 plus x times 2 will equal 50 plus x times 1. So 17 plus x times 2 will give me 34 plus 2x. And 50 plus x times 1, well, that's just 50 plus x. Subtract x on both sides. And subtract 34 on both sides. And we get that x is 16. So I need to add 16 consecutive creature cards. If it's not consecutive, then that would mess up our percentage, so it has to be 16 consecutive creature cards. That's it for today. Let me know if you have any questions when you get to the homework.